Engineers that start their careers have difficult times choosing between disciplines and the technologies to use and studying properly. And in this video, I would like to cover how I studied, and how I still study. And in the context of this, I want to address a user's email, a viewer's email that I received. So you can always reach out to me via email. I'm sometimes receiving emails and I try to address all that I can. And in this video, I would like to dedicate a video towards that we can all go over together, because I think it addresses a common pain point that you all have. And that is starting your career as an engineer and choosing paths. And yeah, so let's just go over the email. I anonymized it, at least partly. I just edited out the name. So let's just have a look at what is being written here. I've already opened the email in Vim. Let me just move out the paragraphs and the upcoming paragraphs out of the way, and let's address each sentence individually. Dear Daniel Hirsch. Okay, that's my name. My name is RB, and I'm an aspiring embedded systems engineer reaching out to you with immense respect for your work and expertise. Oh, thank you. But I think that's a bit too much. I'm not that experienced, really. Watch my videos, you will immediately know that I'm not that experienced, at least in some technologies. Maybe I know some things, but not everything. And I think there are far more other people deserving immense respect. Anyways, I'm always trying to record helpful videos, of course, for you, and make them interesting and also relatable. So, yeah, I appreciate those words. I'm currently an intermediate, continue quote. I'm currently an intermediate Python programmer and will be starting my computer and electrical engineering degree next September. Good. It's interesting to me how some people claim they are intermediate Python programmers already. Intermediate is quite much, I would say. As an intermediate Python programmer, you should already be able to get a job. If you're already intermediate, and I'm looking at this from industry perspective, if you're intermediate level, you can really move things and make stuff happening. Then the choice to be a computer engineer, then the choice to study something related or closer to electrical engineering is quite surprising, because Python and electrical engineering, I know that the degree here is computer and electrical engineering, but what you refer to is a cross-interdisciplinary degree. There the choice is interesting. Why don't you go into computer engineering if you are intermediate in Python? Then you could really sharpen your skills in that direction. Python is quite high level. But maybe that's the only choice in your location. I don't know which location you're writing from. And possibly the university you are nearby you is only offering this cross topic degree here. All right, but let's not stick out too much here, because I want to know what the questions are. By the way, if you want to study computer and electrical engineering, Python is very, very good. If you say you are intermediate, then the degree will only be the tool to enter the door in the end. I also studied electrical engineering, by the way. So I was sitting in the same boat as you. I studied electrical engineering, and when I studied electrical engineering, I didn't know that much programming. I have done some HTML. I have done some very, very simplistic programming. I have coded some keyloggers and stuff like this, but on a very, very basic level, just copying YouTube tutorials. And I thought I was going to be an electrical engineer, but that didn't happen because when I took my courses, I discovered that for some reason, the programming part was by far the most fun. Electrical engineering is very focused on mathematics, and computer engineering is very focused on logic. And although both are very related, I think some people are leaning more towards one over the other. And I discovered during electrical engineering that I love programming and it's really enjoyable and you get results very quickly. You don't need hardware. You don't need to set up measurement devices and measure voltages and that stuff. And so I just took courses focused on software, on programming, on software engineering, and those were really nice in comparison to the hardcore mathematics of electrical engineering. Alrighty, let's go to the next paragraph in this mail. As I prepare for college and work towards my long-term career goals, I'm embarking on a focused learning phase. Your language is really uptick. I'm embarking on a focused learning phase. I sense that you read a lot of books. I'm eager to deepen my Python skills by learning Discord.py for a personal project and Django to build a web application for my father's business. Okay, that's good. It would be really, really interesting what kind of web application you're doing. And yeah, possibly you can already, I don't know what the rest of your email is, but you could possibly start some working student job, I think, in parallel to your studies, because it seems like you really have some skills. If you say you're building a web application full stack with a backend, even if it's simple, and a front end that you can do something with, that's already really valuable, and that separates you from a lot of applicants really quickly. Especially, well, when I got my first job as a working student in parallel to my studies at university, I was not able to build a full web application. I applied and I had a small portfolio of a small Java software that was able to brute force passwords. I think it was zip files. And I wrote a small brute forcing algorithm that could crack small zip files. Oh, and the interesting thing here is that this idea was sparked because I received a document from my bank, and that document was encrypted with zip. And the password was a small, I think, 5-digit number, and I thought it was just numbers, 5 digits and just numbers. And I thought, wait, why is my bank reaching out to me with such a poorly encrypted method? and then I just tried to prove the point myself and cracked that document, or at least the zip wrapper around the document, using this small project, and it was crackable in, I think, under 2 seconds or something like that. And that was the first small project I did, and it was really simple, so it is far below building a complete web application. And I applied to a couple of jobs, and I was even rejected by some employers because they said what my project did was illegal, even though I just cracked a document that I received that was my own data. So my project was illegal, and that doesn't align with the company's philosophy, and therefore they reject my application. But another employer accepted me, luckily. And that is the small story regarding personal projects and entering your career. So what I did was really, really small. I also wrote a small image to ASCII converter that, well, took in an image and converted it to ASCII characters that resemble that image. And during the application, I was asked by the employer about this algorithm that I used and how sophisticated it was. And one interesting question I got was whether I somehow dynamically determine which character to pick based on the brightness of the color in the image. So what I did was I took in an image, converted it to grayscale, and based on the brightness of the pixel, I assigned a character. And the brighter the pixel, the denser the character that I chose. Let me just open up Paint to showcase that. So as you can see, let me just make this black right here. Let's imagine that this green box here is a simple pixel. This is a pixel, okay? And I want this to be very bright. If I want to make this very bright, I choose a character, for example, this hashtag character that fills a lot of the pixels inside the square. If I want to resemble a dark color, I'll either use a space, so that is completely black, of course, or some intermediate color. I'll choose a dash or a single point, just like this. So based on what I estimated was dark and what was bright, I chose different characters, but those were hard-coded, and the employer asked me whether I could somehow dynamically determine the character's brightness, and that would involve evaluating each character somehow dynamically and checking how many pixels it fills as a percentage of as a percentage value, maybe between 0 and 1. Yeah, but of course I didn't do that. But if you have such a project and you create an image to ASCII converter, that might be something that you would like, that you want to do, and you would have to scan the character set that you are using, or rather the font. You probably have to scan the font, because in different fonts, different characters occupy different pixels. Okay, so next sentence. Simultaneously, I recognized the foundational importance of C for embedded systems, and I plan to study it using the highly recommended book, C Programming, A Modern Approach by K.N. King. Okay, let me just open that book. I don't know, I think I have heard it before. I don't know if I have read it. C Programming, A Modern Approach. I have seen this book before. It's quite expensive where I live, but I'm sure there's a PDF online. Okay, seems to be some complete course on C. Sounds solid, okay. I recognize the foundational importance of C for embedded systems, and I plan to study it using the highly recommended book C Programming, A Modern Approach by K.N. King. Okay, yeah, if you want to learn C, grab some book and read it, or at least read the introductory chapters and see how far it gets you. That's a good approach, a very good approach. And I think that too many people nowadays disregard the importance of books. I've learned so much using books, and I would say much more than watching YouTube tutorials, because you can't just read a book and not understand it. If you read a sentence and you don't understand it, you can't continue reading the book, because everything that follows up will probably depend in some way on that sentence. So you have to go back and reread that sentence until you understand it. Nowadays, you can even use some AI or Google to ask for the meaning of that sentence and maybe break down the individual names. But in a full course, such as the book you're suggesting, the C Programming: A Modern Approach by K.N. King, I would assume this is a book that builds up this topic from zero, so you can read it without having to look up things. And the best thing about reading books is exactly that. They build up knowledge from zero. They don't assume knowledge, at least these introductory complete course books. And you can rely on them to give you very good explanations of how things work. And these explanations that you will read about, you will understand, and they will be universal. If you watch a YouTube tutorial on C, it usually showcases a specific example. It does not always give you explanations or ideas or a deep understanding of what you're doing. And that's the big difference to a book. Of course, there are exceptions, but I find that reading a book and really focusing on a sentence really does something else with your brain, because you're in silence and you have to process your understanding yourself. So the information is not pre-digested, at least not by someone operating a YouTube channel. Usually that's another point. Usually the people who are writing books are way more qualified to explain stuff as compared to YouTubers. And that's why you can rely on YouTube channels to gather inspiration. For example, you watch this channel, you watch me coding things here, making stuff happen, and I try to explain stuff. But you will only really process information if you read about them. If you read about it. Okay. Also, this is another general rule. Reading takes a lot of time. And nowadays we're distracted by a lot of short form content, YouTube Shorts, Instagram Reels, TikTok. But not only that, even a 5-minute or 10-minute video on YouTube is short form content from your brain's perspective. We evolved in prehistoric times and not much happened. So our brains evolved to process things slowly and to think about things. And anything that your brain faces for a short period, and I would say anything under 20 minutes, maybe under 15 minutes, something between 15 and 20 minutes, if you expose yourself to information for under 15 to 20 minutes, you will not retain that information. And that's the reason why university courses and lectures are usually 45 minutes, sometimes 1.5 hours, depending on where you live, maybe 1 hour. But it's never a 15 to 20 minute lecture, because you will never retain that information. And that's also something that books do much better. They are, in order to understand things, you have to busy yourself for a period of time that is usually longer than 20 minutes with that information. I usually set a timer, or sometimes if I'm not motivated, I set myself a timer, maybe on my phone, maybe on the computer, for 30 minutes. And then I read that book until the alarm goes off. Then I finish the sentence. And within those 30 minutes, I have learned something and I will retain that information. So that is something important to know, I would say. Don't rely on YouTube to learn things. Reading a book, a fundamental book such as C Programming, A Modern Approach, even though I haven't read it before, I would say is a superior approach to learning than anything else. All right, let's go to the next paragraph. Oops. Okay, there it is. The bottom one. I would be incredibly grateful if you could share some insights into your own journey. Okay, I think we've already done some of that. Specifically, I'm curious about, let's see. I'm curious about how did you approach learning C and Python in your early days, and what methods or resources did you find most effective? And yeah, I think that's what we already hinted at, or that's what I already hinted at before. The real learning only happens with long-form content. It does not happen through YouTube videos. It might happen with... No. I would say courses online, full programming courses online. And there are a couple of 4 to 8 hour videos, or even longer, about specific technologies. They might be superior to individual videos, but I think I would like to refute that thought, because they are divided in very small digestible chapters, and by the way, that only take 5 minutes, 10 minutes at most, and by the time you process the information, you are already in the next chapter dealing with the next programming concept. So courses, I think I've never really gained any long-term knowledge from courses online. So videos and courses are only good to have a small glimpse at technologies, maybe gather inspiration, but to learn knowledge that you can apply everywhere, universal knowledge, read books. I have, by the way, put 2 books under all my YouTube videos. One is for C. It's just an original C book by the original creators of C. So I linked that. I read maybe half of that, and as you can see, that's enough knowledge for me to put out some projects. And it really starts with 0. And the other book is about Vim, which is this text editor environment you're seeing on my screen, which is, I would say, also very, very useful universal knowledge. And that's what you have to focus your reading on. If you really want to learn something, focus on universal knowledge. And Vim is just a text editor. It's just basically, if you think about it too naively, it's just a text editor software. So how is that universal knowledge that can be applied everywhere? For me, it is universal because at my job, and I guarantee you at your job, regardless of whether you're going to be a Python programmer, a front-end dev, or a data engineer, an AI engineer, it doesn't matter. Even if you're not a programmer, even if you're a whatever, at some point in your career, you're going to edit text files. I'm talking about technical jobs here, so not everybody's going to edit text files. And you're going to edit text files on different machines. Now, it would be a complete waste of time to have to install and set up IDEs to do all of that. And if you learn Vim, which is installed by default on 99% of Linux distributions, I would say, you will feel right at home on whatever machine you are working on, and this is a huge advantage. So on every machine, on almost every machine on Earth, in the universe, you will be able to edit files, text files, code files, whatever. You can edit anything, configuration, code, deployment stuff, whatever. You can edit anything in Vim. And that's what makes this software universal to me. It's so widespread, but it's nowadays not many people know it. And the first thing that most colleagues go through when setting up a new machine is they install all kinds of bloat, which is fine. But if you just need to log into some machine and change whatever small configuration there is, or upload a file somewhere, edit it, change a title in an HTML document, and that's it, then you can leave the machine. You have incredible advantages by knowing universal software, or maybe universal concepts such as editing text from the terminal, Vim, and of course, learning the programming language C is also universal in and of itself, because it's the first language that introduced the syntax that we're all familiar with, involving specific loops, the notation that we're all using the parentheses, quotes. Many concepts of variable data types were introduced with C. So it's very universal knowledge, and by learning C, you don't only learn C, you learn every language, almost every language. Yeah, so my approach to learning heavily leans towards reading. Okay, and many people would recommend you to do otherwise. Just start coding. Just start coding a small racing game or whatever. No, you have to learn the fundamental concepts first from scratch. You have to have a good understanding first of very simple concepts, and that's the best thing. Programming is not difficult. C and Python are not difficult. There are very, very simple concepts that you have to understand, and then you can use them everywhere in the language. And that's what most people fail at. They try to do something overly fast, and then they don't really understand what they are doing, and they don't really learn. So learn the small details, and the complexities will solve themselves on their own. On this YouTube channel, that's, by the way, the reason, all of that is the reason why I record such long form content. Right now I'm already talking for 28 minutes and 30 seconds. And if I talked for only 10 minutes, or even 5 minutes only, there are tons of short form content like that. If I talked for such a short time, you wouldn't retain anything. So if you're listening to me and you watched this video until now, by the way, thanks a lot. Your attention span is exceeding that of most other people nowadays, by far, and you will retain this information that you hear here. And possibly I have tipped you toward reading books, which I would be very very happy about. All right, let's have a look at the next question. How do you continue to learn and stay proficient in these languages and new technologies to this day? I don't think I think this continuous learning as an engineer is partly a misconception. I don't really continue to learn and stay proficient that consciously. I just try to continually refine my understanding of the fundamentals. And if you continually refine your understanding of the fundamentals in computer engineering, for example, what are fundamentals? Fundamentals are structure of code, syntax, basic syntax that languages have in common, maybe performance, complexity, that is something fundamental. Algorithmic complexity. What distinguishes an algorithm to be O1 or ON or ON squared? If you understand those basic fundamentals of languages, then you're good to go. Other fundamentals might be certain types of databases and how they came to be. How can you store data? What is a database? Basically, a database is just a file. But how's that file arranged internally? Is it in some kind of tabular format? Is it does it allow references to other rows inside itself? Does it reference other files? Does it keep backups of itself? So understanding databases, for example, only breaks down to those simple questions. And yeah, I would say I continue to learn by deepening the knowledge based on what interests me. So I started learning, of course, by having a look at programming languages in scope of university courses maybe, or some small side projects, and I made something happen. Okay. Then I read books and improved my understanding about those technologies. But over time, you will develop, maybe through reading or maybe through experience, somehow you will develop an understanding of technology that will go beyond even that. And you will understand very, very, very basic and fundamental concepts even better. So you don't really continue and chase after new technologies. You sharpen your explanation, your explanatory understanding of the computer as a system, as a whole. You improve the model of a computer in your brain to understand to understand all the concepts that it uses to work. And by this continuous refinement of your understanding of this whole system, you are able to keep up with all the technologies. And it doesn't matter whether you use a specific library, whether your employer wants you to change to a different version of a library or whatever. Everything breaks down to very simple concepts. All right. Let's have a look at the next question, if there is one. Yes. When tackling something completely new, what does your typical workflow look like? How do you break down the learning process and integrate new concepts into your coding practice? So when tackling something new, I've recorded plenty of videos on that. Usually I start somehow by being completely clueless, and then I start working on something based on the understanding of the system that I already have. So you can't really develop something without understanding it. If I start, for example, a small game in C, let's say Pong, then I have to have some clue of what that game does. It's impossible to start from zero with absolutely no knowledge. You have to have some previous knowledge. For example, I know that the Pong game uses graphics. It's not a terminal-based game. It means I will have to look up some graphic library. Of course, you break down those things to very basic necessities. Then I know that Pong moves. In Pong, players move and a ball moves from one player to the other. That means I will not only render a static image, but I will have to have some mechanism that refreshes the screen. Do all graphics libraries deal with that? I don't know. There are probably some static image generators, but I can't use those. So I'm looking for some library that can render and update graphics on the screen. It doesn't matter which library, by the way. I just need some library that suits my requirements. And whether you make what you want happen in SDL, which is one library, or in Pygame, in Python, which is a Python library for developing games, or in OpenGL, which is a very low-level graphics library for C, actually for any language. Which library you choose doesn't matter at all. If you tackle a problem, you have to break down your own understanding of what you need, and then you look up the things that you need. And you always start with the very simplest necessity. So if I develop this Pong game, I start with a new file, I write a simple hello world, and I make it compile. Okay, I started with a simple C program that compiles. Awesome. Now, it prints out a message. That's already good. But I don't have the graphics I need. How do I get the graphics I need? I put in the library I need. I just pick some library. You can use your knowledge to choose between libraries. But for that, you have to research the libraries, create your own explanations of what they are capable of and what they are good at, and then you choose between some library. And this decision involves also some research. Yeah, and the more you know, obviously, the better your choices are. But you will only know more through either having fundamental knowledge or experience, but both the fundamental knowledge from books and experience are things that you don't and you will never get from just tackling something quickly. You will never get that knowledge from looking at short form content. Never. All right. How do you break down the learning process and integrate new concepts into your coding practice? Yeah, I break down the learning process by... I don't really know if I break it down. What does breaking down mean in this context? You probably mean something like breaking down what you want to learn into categories, into subtopics. You can't really answer this universally because to be able to break something down, you already need to have an understanding of it, obviously. Let's say I want to find out how, when I move to a new apartment, how do I get a kitchen into that apartment if it doesn't have one yet? So far, you have no knowledge about that. Or I have no knowledge about that. So how do I break down the learning process without any information? I have no starting point. Basically, you always have to get the information first. You have to read up things slowly. You have to understand things from fundamentals. You have to look up things and then you integrate what you learned into your decision making, or into your breaking down of the topic. For example, when I move to a new apartment and there's no kitchen in that apartment, I look up how different people online got a kitchen in their apartment, and then I learn, oh, there are different ways to do it. Either you get a used one from someone, you pick it up and then put it in your home, but that opens a huge plethora of other follow-up problems, such as how do you adapt it to the room size you're dealing with. And the alternative would be to buy it from some store, to measure the room beforehand. You buy it from some store and then you make sure that everything fits. Or the third alternative would be you have someone from the store come to your new apartment and measure your flat and put it there. But basically, you break down the problem by thinking about different possible ways to do it. And then you need to explain to yourself somehow which option is the best one. Based on what you know, of course. For example, when building a kitchen, or let's move away from the kitchen building. It's probably a poor example. No, let's stay there. When building a kitchen, you might have to consider, do you have any craftsmanship skills? So you have some you integrate some information about yourself into that decision making. Then, do you have money? Do you have time? Do you have relationships to someone who works at the kitchen store? Do you have relationships to someone who works at a kitchen store? Yeah, good example. So basically you gather information and then you think about that information and evaluate yourself in different positions. When I want to develop something, I gather information. How did other people do it? Okay, someone used a library, SDL. Someone else used another library, OpenGL. Someone else built everything from scratch by writing assembly code. Now I put myself in that position, in those three different positions, and think, do I have any previous knowledge of SDL? No, but I know where to get it. I know where to get it because I'm watching this YouTube channel here. I know where to inspire myself, maybe. And then there's documentation that I can look up. Do I have any OpenGL knowledge? That would be the alternative. No, not really. And I also don't know if there's good documentation on that. Okay. Do I have any assembly knowledge? No, not at all. And through that approach, you have set up three different alternatives, three options, and you have evaluated yourself in that position, and then you choose the most rational one. And I think the most rational one would be to start with SDL in this example. Yeah. So that's breaking down the learning process in integrating new concepts. Well, integrating new concepts means to integrate new concepts, that's the same thing. Breaking down a learning process and integrating new concepts is the same thing. To integrate new stuff into your coding practice, you have to gather new information. You have to expose yourself to the world, gather information, and then evaluate, can you change something about your coding practice? Basically, everything breaks down to continuously exposing yourself to good information, good long-form information that gives you new insights. And don't trash your brain with short-form information that will only clutter your head. And that's something I really frequently see in the comments here. People complain about me using a specific library. Why do you use SDL? You have to code it from scratch. You have to code against the operating system library. That's not from scratch. Or, you're using the wrong random number generator. That doesn't work. That's not secure enough. Yeah, you might be right. Maybe your approach would be even more skillful if I applied it. But it doesn't change anything about the principles that are being shown in the videos. So it doesn't really matter which specific technologies you use. You have to choose the best one that you are aware of at a given time. Then while working on that technology, you expose yourself to new in-depth information, and you continuously integrate all of that into your practice, of course. Let's go to the next question. Okay. I'm also at a crossroads regarding my learning priorities between January and September next year. Python offers more immediate utility for my current projects, while C is a long-term investment for embedded systems. Given that my college curriculum will cover both hardware and software, do you think it's more beneficial to dive into C now, or should I focus on the Python tools first? It doesn't matter at all. Because both technologies deal with computers, you will improve your understanding of computers regardless of which specific technology you apply. Because you can only properly apply C and you can only properly apply Python if you have a proper understanding of the computer as a system. So both will benefit you. This is really important to understand. If you understand C really well, or if you want to understand C really well, you have to understand computers really well. And if you want to understand Python really well, ideally you have to understand computers really well as well. It doesn't really matter. Of course, in C there are some low-level details such as pointers, but or specific memory accesses. But to be good in either C or Python doesn't really make a difference. The world's best programmers in C, they are geniuses. The world's best programmers in Python, they are geniuses. They are on the same level. It doesn't matter. And I would say if your curriculum covers both hardware and software, just choose whichever you like more. I have a feeling that you try to force C somehow. And I completely understand that, but it seems that Python is natural to you because you already use it in some projects. Now that you're exposed to electrical engineering, you also want to use C, or you want to spend time on C. You can do that, of course, if you're interested. But most importantly, have deep understanding of either of them. It doesn't really matter. And if you understand Python deeply, you will understand C deeply. No, you won't. Pointers are completely different. Python wraps everything in libraries. No, this doesn't work. Yes, it does work because if you're a good C programmer, you won't just code everything from scratch. You will also use libraries. So the actual day-to-day working will not differ that much in C or Python. Of course, the application sometimes differs. C will do more embedded stuff in C or more low-level stuff. And in Python, you will probably tend to do other things such as data analysis, AI, whatever. But that is actually an arbitrary choice. You could do either in C or in Python. It's completely arbitrary. It's just that the group that identifies themselves as embedded devs have focused on C. Yeah, obviously. I have arbitrarily chosen C over any other language, including assembly or C++ or whatever. And the group that identifies themselves as higher level engineers such as AI, data, statistics, whatever, maybe for some full stack devs, they have agreed that Python is their tool of choice. But it's just a tool, and you don't really need to decide on either of them. Just do whatever interests you and continuously improve your understanding of computer systems as a whole, and you will be very good at both of them. I guarantee you that if you reach out to the best C programmer now, they will have Python knowledge, and if you reach out to the best Python programmer, they will have C knowledge. Guaranteed. And they will have an interesting opinion that they use to explain to themselves why they use C or Python rather than the other one. But it's just an explanation. It's just a justification for themselves. There's no real difference. So given that your college curriculum covers both hardware and software, do whatever you want. And by the way, if you focus on whatever you want, you will become good at both. Guaranteed. I guarantee you that someone who doesn't work out and never goes for a run is worse at swimming as someone who always rides their bike. Okay? Because even though someone is riding their bike and they are training for bike-specific fitness, they will be better at swimming than someone who doesn't do anything at all. So if you continuously improve yourself in some area, then you will be better in all related areas as well. Yeah, okay. Thank you for considering my questions. Any advice or guidance you could offer would be invaluable to me as I navigate this exciting path. Sincerely, RB. Yeah, I think I've answered or tried to answer all your questions in live. You're reading and evaluating them sentence by sentence. If any of you other subscribers and viewers have any advice for RB who wrote me this mail, then please put it in the comments, and also put your opinions on what I said in the comments. And please let me know if you like this format where I respond to user mail. And please also let me know where you disagree with me. That would be incredibly valuable. Have a good time, and see you in the next video. Bye bye.